fraction.
Good. Okay, the next part of 1.4 will be looking at the graph, and we'll be talking now about the zeros of the graph. When we have a graph, graphically finding the zeros is simply identifying the x-intercepts. The x-intercepts. Okay, and I do know how to spell, as long as it's not more than 4 or 5 letters. X-intercepts. Those are also known as the zeros. And later on, when you really get sure of it, we're going to change and start calling them the roots. Because math is like that. We have many words for the same thing. Roots, because if x were the ground, this is where the graph crosses underground. Zeros, because this is where f of x is 0. F of x. In other words, the y value. X-intercepts, because it's where the graph intercepts the x-axis. Okay, so algebraically what that means is we're going to have to set the function f of x equal to 0. So for example, if f of x equaled 3x squared plus x minus 10, we would begin by setting 3x squared plus x minus 10 equal to 0. That's our first step. The black writing is the result from the last step. The red is what we're doing it to get to the next step. In other words, once we set this equal to 0, now we have to factor this quadratic. Once we factor it, we know that any time you have an answer in multiplication that is 0, then one or the other of the factors can be 0. And that's the only way that this answer can be 0, is if 3x minus 5 is 0, or if x plus 2 is 0. And either way makes it true. So what we do is once we factor, we set each factor equal to 0 and solve for x. So add 5 to both sides. Divide both sides by 3. We find that x equals 5/3. Over here, subtract 2 from both sides. We find that x equals -2. And so the zeros of this are x equals -2 and x equals 5/3. Now what this might look like, it's quadratic, so it's going to be a parabola. And we're going to have an intersection at -2, and we're going to have another one at 5/3. 5/3 is just before, it's a third before you get to 2. And so this graph is going to look something like that. That's what the zeros are. This is the algebraic way to find them. Looking at the graph, you find them by just identifying the x-intercepts. Okay, let's look at another example that's not quadratic. Here we have g of x equals the square root of 10 minus x squared. See if you can follow along with the way that I've solved that. To undo the square root, the first thing that we do is we square both sides of that equation. And once we square it, we remove that radicand. And 0 squared is still 0, and the square root of something squared is just that something. Now we begin to solve it, and I've had a question in the past, why am I adding the x squared instead of subtracting the 10? Well, I'm just trying to skip a step. This would leave you with a -x squared if I moved the 10 over first. And then I would have to undo that negative sign. So it's just easier. I add x squared to both sides, and then I have x squared equals 10. I don't have to do that step to get rid of the negative sign. The last step is to square root both sides. The square root of x squared equals the square root of 10. the square root of 10. And we have to remember, very important, that this can be the positive or the negative. For instance, if it was the square root of 16, the answer could be 4 or negative 4, because either one of those numbers squared is the same. Okay, so always remember, when we're square rooting x squared and square rooting the other side of the equal sign, it's always going to give us two values, the positive and the negative value. Okay, one more idea before we're finished today. Actually, we're going to look at two more ideas. And this is the notion of increasing and decreasing. If we look at the graph, on this portion, from here to right here, this function is increasing on that interval. It's increasing, it's going up. And you get onto this interval, and it's decreasing. Because f of x, the y values, f of x, are going down. You get back into this interval, and it's increasing again. We could say, if this was A, B, C, we could say that f of x increases on negative infinity all the way to b. But it doesn't include b. At this one point, it's not increasing anymore. This one point is what we call a maximum. This is the highest that the graph goes. And again, it decreases until it gets to this point. This point is called, logically, the minimum. So f of x increases from negative infinity to b. b is a maximum. It decreases on, everybody said, the interval b to c. Notice I'm using parentheses and not brackets. Brackets would indicate that it includes that point. It is not decreasing at c. c is a minimum. Thank you.